Hello, today we're going to talk about mastery topic number 4, trigonometry. Starting with number 1, find the following values from memory or draw a unit circle. So the idea is if you know your unit circle, you should have an easy time with all of these values. Just a reminder that the first couple ones, cosine, this is a radian measure. This is the angle, okay? Same thing right here. Same thing right here. However, when I see arc, or an inverse, if I saw that, these are the actual values, and I'm looking for an angle. Knowing the difference, cosine, sine, and tangent of an angle produces a value. However, arc sine of an angle, arc sine of a value produces an angle. So let's start with the first one, cosine of pi over 2. Well, you do need to know your unit circle, so let's draw that down here. We do know that right here belongs 0, and while we're at it, we're at 2 pi. Well, since we know a full circle is 2 pi, we know half of a circle is pi, and we know a quarter circle would have to be pi over 2. And then down here, since this is half a pi and this is a full pi, this would be 1.5 pi's, so that's why we have 3 pi over 2. Now, the only thing you really need to know is the special right angles formed in the first quadrant, because once you know those values, you actually know all the other values using reference angles. So the three angles are pi over 3, pi over 4, and pi over 6. Well, we know pi over 4 is in the middle because that's half of pi over 2, or a quarter of pi. And then this would have to be pi over 6, and this would have to be pi over 3. 1/3 of pi over 2, so since pi over 2 is right here, 1/3 of that would have to be pi over 6. So now, once we have those three, let's label all of the values for the x and y. Now, when we label the x and y values, they correspond with the cosine of theta values and the sine of theta values. So in this first quadrant, I'm going to be labeling these three values particularly. What I do know is that since this is pi over 6, the first angle is pi over 6, it'll have to be longer than it is taller. Well, if it's longer than it's taller, that means the x value is bigger than the y value. Well, if you remember your special right angles, we only have three values to work with. 1 over 2, root 2 over 2, and root 3 over 2. The biggest one of those is the root 3 over 2, and the smallest one of those is the 1/2. Since we know what pi over 6 is, pi over 3 is sort of a symmetric angle along the line y equals x. So what we do is we just flip over the x and y values here, since it is also shorter than it is taller. Or sorry, not as wide as it is tall. And then finally the middle one is the one that's usually pretty obvious, based off of a 45, 45, 90 degree triangle. We have root 2 over root 2. Or sorry, root 2 over 2, comma, root 2 over 2. Now, everything in the other three quadrants is going to mirror those. So if we know this first quadrant, we're good. So let's start with pi over 2. Well, cosine of pi over 2. Well, if we needed to label this one, cosine of pi over 2 is the x value. Well, since this is a unit circle, it has a radius of 1. Well, this point on the xy plane would have an x value of 0 and a y value of 1. Well, then the cosine value of pi over 2 is the x value. Remember, x is cosine of theta. So that means this will be 0. All right, for the next one, sine of 11 pi over 6. So now where is 11 pi over 6? Well, here is pi over 6. Here will be a version, something pi over 6. Here will be a version of it, something pi over 6. And then here will be a version of it, something pi over 6. Now, the way I usually remember these is I remember that in the first quadrant, everything has a coefficient of 1. in the second quadrant, everything has a coefficient that is 1 less than the denominator. So if the denominator here is 6, the coefficient in front of the pi is a 5. Same thing would happen for these three values. This would be something pi over 4, and this would be something pi over 3. If I take 1 less, it'd be 3, and if I took 1 less, it'd be 2. So everything here is denominator minus 1 times pi over that denominator. Here, in the third quadrant, we're looking at the denominator plus 1 times pi over the denominator. So here, if I have a 6, I will have 7. Finally, in the last quadrant, the fourth quadrant, we have 2 times the denominator minus 1 times pi over the denominator, which means if the denominator is 6, 2 times the denominator is 12 minus 1 is 11, and that's what the angle I'm looking for is 11 pi over 6. So 11 pi over 6 is going to have the exact same coordinates here, root 3 over 2 comma 1/2, except because you are in the fourth quadrant, the cosine value is still going to be positive since we have a positive x value, but since we're below the x-axis, it's a negative 1/2. So then the answer here is negative 1/2. While we're here, let's take care of letter E, because that's also another trig function as it is, not an inverse trig function. Cosine of 5 pi over 4. Well, if I just analyze this, 5 pi over 4, that's 1 more than the denominator. That means it has to be here in the third quadrant. And this is 5 pi over 4. Just a reminder, you're going to have the exact same x and y values as pi over 4, since it has the same denominator. Those are all based off of reference angles. Except you have to think about the sign. Now, because we are in the third quadrant, x and y are negative, so that means this will be negative root 2 over 2. Okay, and finally, we have arcsine, arctangent, and arccosine. So I'm going to clean up some of this work. Okay, so when I'm asking for arcsine of root 2 over 2, some things that you will need to remember is that arcsine only deals in the first and the fourth quadrant, okay? And its range goes from negative pi over 2 to pi over 2. Arctangent has the exact same range, negative pi over 2 to pi over 2. Arccosine has a little bit of a different range. It goes from 0 to pi. So if I'm asking for a value like arcsine of root 2 over 2, what I'm asking for is where is sine root 2 over 2? In other words, sine of what angle equals root 2 over 2, but it is very, very important to understand I'm only dealing in those first two quadrants. So I only care right here for that angle. So where's sine root 2 over 2? Where's the y value root 2 over 2? Spotted right there. So then that answer would be pi over 4. I'm going to jump to letter I. Arccosine of negative root 3 over 2. So I'm looking for an x value, since it's cosine, of negative root 3 over 2. I see that right here. I have an x value of root 3 over 2. But since I want a negative one, now again, cosine deals with only the first and the second quadrant, so I do not use the fourth or the third quadrant, not here, not here. So my answer has to be right here. Now, I erased that angle, but if you remember, the rule was the denominator minus 1. So if the denominator is 6 minus 1, that would be a 5 pi over 6. All right, and then finally, we have arctangent. Now, arctangent requires us to know the tangent values. Well, an identity everybody should know is tangent of theta equals sine of theta over cosine of theta. So what I'm going to do on the side of these is, because I have the cosine value and the sine value, I'm just going to take the sine value divided by the cosine value, and really I'm going to ignore the 2's because everything has a denominator of 2. So then this is 1 over root 3, or root 3 over 3 if I rationalize it. If I take root 2 divided by root 2, I'll get 1. And if I take root 3 divided by 1, I'll get root 3. So all of these are the tangent of theta values. Now, it's really good to remember these three values. It'll make your life a little easier. But one thing I always remember is they're always increasing. So this is the smallest, middle, biggest. Arctangent of root 3, well, that's what I'm looking for right here. And it's positive root 3, and it's in the first quadrant. So the angle that corresponds to that is pi over 3. Knowing the unit circle is going to go really far for anyone that struggles with these types of evaluations, and you do need to know them. One point to make right now is that when I am dealing with arc sine and arc tangent and arc cosine, you only get one answer. They are all functions. Functions have one input and one output, so don't give me multiple angles. It only has one answer. All right. Next couple ones, solve 2x minus 1 equals 0 for x between 0 and 2 pi. Okay, so we're solving an equation. Basically, get x by itself. How do I isolate x by itself? I'm going to first add the 1. Then I'm going to divide by 2. And now I have to ask myself, on the unit circle, when does sine of x equal 1/2? Now, this is not a function as much as I have one input, one output, because I'm asking what values of x in the unit circle can give me 1/2, which is different. So when is sine 1/2? Well, if I think about my unit circle, 1/2 is the smallest of values. So I don't want a tall triangle. I want a very, very short triangle. And what angles are right here and right here? Well, those angles would be pi over 6 and 5 pi over 6. Okay, the next one. Sine squared of x plus sine of x minus 2 equals 0. Well, if I'm trying to solve this one, well, it kind of looks like a quadratic. It resembles y squared plus y minus 2 equals 0. So what I'm going to do is I'm going to treat it like a quadratic. Something I would do right here is I would factor. So I would factor this, and I would take out a sine of x and something, and a sine of x and something equals 0. So then if I actually analyzed this equation, what multiplies to negative 2 but adds to 1? Well, that'll be positive 2 and negative 1. So I'm going to put plus 2 and minus 1. And then I'm going to set each of those equal to 0. So when does sine of x plus 2 equal 0? Or when does sine of x equal negative 2? And then when does sine of x minus 1 equal 0? Or when does sine of x equal 1? Well, sine of x equals negative 2 is never going to happen. Okay? On the unit circle, the range of sine, which is the y value, how high and how low, only spans from negative 1 to 1. So outside of that, it's not possible. However, sine of x is equal to 1 does occur. So when does the sine value, when does the y value equal 1? Well, pi over 2. And there you go. All right, number 5. If cosine of x equals 5 over 11, and sine of x is less than 0, then tangent of x is equal to what? So I'm not really solving for an angle here because I'm not asking you what x is. I don't actually care for what x is. I don't care for the angle. I just want to know another value of tangent of x. Well, remember, sine, cosine, and tangent come from SOHCAHTOA, which are all based off of the right triangle. So because 5 over 11 also does not resemble a special right triangle, what I'm going to do is I'm actually going to draw a triangle, but I got to figure out where this triangle is going to live. Well, since cosine of x is positive 5/11, we know the x value has to be positive, so it can't be here and it can't be here. But it does say the sine of x value is negative, so that means my triangle actually is drawn like this. If I remember, cosine is adjacent over hypotenuse, so the adjacent side is 5 and the hypotenuse is 11. Now it's my job to figure out what the missing opposite side is. Well, then I would do Pythagorean theorem, so 121 minus 25 gives me 96. So that means this side is the square root of 96. So then tangent of x would be opposite over adjacent, so square root of 96 over 5. Now, can square root of 96 be reduced? Well, it's 4 times 24, or 16 times 6. So then this would be 4 root 6 over 5. Okay, last problem. Find an equation for the following graph. Now, your job is to identify, is this a sine graph or a cosine graph? So, if you remember, sine graphs always start from the origin. Cosine graphs always start from either the maximum or the minimum. If I look at this, it starts at the origin. So I'm using a sine graph. The next thing is, does the sine graph go up? And if so, that would be a positive sine graph. Or does the sine graph go down? If so, that would be a negative sine graph. Well, starting from the origin, I am going down. So already I know I have negative sine of something in front and something times x. Do not forget the x inside. So this term in front, if you remember, is the amplitude. This term in front is not the period, but it's the value of b that helps us determine the period, which is 2 pi over p. Amplitude is pretty easy to find. From the midline, how far do I stretch up, or how far do I stretch down? Well, since you see a 3, the answer so far as the coefficient of sine of x is negative 3. But then, what is the period of this function? Well, how long does it take for this function to start repeating itself? So if I actually start tracing this graph, I start from the x-axis here at the origin, and I go down. And I have not repeated that behavior, because although I'm at the x-axis again, my behavior is going up. So I'm not going to use that. I'm going to continue, keep going, keep going, keep going down. Okay, I'm back at the x-axis, and my behavior says I'm going down, just like I was right here. So if I actually take this section of the graph, I can copy and paste it anywhere I want, and I have the same exact graph. So my period is how long it takes for it to repeat, which is pi over 2. So in order to find my b value, I'm going to have to do 2 pi divided by pi over 2. Well, if I have to simplify that fraction, 2 pi over 1 divided by pi over 2. I'm going to multiply top and bottom by 2, which would give me 4 pi over pi. Cancel the pi's, you have 4. So then the coefficient in front of the x is a 4. So right now I have negative 3 sine of 4x. We are not asking for any phase shifts. We are not asking for any vertical shifts. The last thing I'm going to look for is, did I answer the question? Write an equation. This is not an equation, it's an expression because it doesn't have an equal sign. So then if I was actually graphing this, I would have y equals. That is an equation, and that completes topic number 4.